How does atmospheric drag affect spacecraft reentry? Imagine a spacecraft gliding through space, preparing to return home. As it enters Earth's atmosphere, a fascinating process begins that shapes its entire reentry. Atmospheric drag is the force that acts against the spacecraft as it passes through the air. Even though the atmosphere is very thin at high altitudes, it still exerts resistance. As the spacecraft descends, the air density increases, making drag much stronger. This slowing effect is what helps the spacecraft transition from orbit to a controlled descent toward Earth. When the spacecraft hits the denser layers of air, it experiences a lot of friction. This friction causes the air around it to heat up rapidly. The heat is so intense that it can damage the spacecraft if not properly managed. That is why heat shields are essential. They absorb and dissipate the heat, protecting both the vehicle and its crew. Without these shields, the extreme temperatures could melt parts of the spacecraft or cause structural failure. Mission planners carefully calculate the reentry trajectory to control how much atmospheric drag the spacecraft will encounter. This helps them manage the heating rate and ensure a safe landing. They adjust the spacecraft's orientation and shape to influence its ballistic coefficient, which is a measure of how much drag it experiences. Some small spacecraft even deploy devices like parachutes or drag sails to slow down further and steer their descent. Solar activity also plays a role in how much drag the spacecraft faces. When the sun is more active, it heats Earth's upper atmosphere, causing it to expand. This makes the air at orbital altitudes denser, increasing drag. As a result, spacecraft may need more frequent adjustments to stay in the right orbit before reentry. During periods of low solar activity, the atmosphere is less expanded, and drag is weaker. In essence, atmospheric drag is a key player in spacecraft reentry. It helps slow the vehicle down but also creates intense heat that must be carefully managed. Proper planning and understanding of these forces are vital for a safe and successful return to Earth. Astronauts and mission teams work together to ensure that every detail, from trajectory to heat shield design, accounts for atmospheric drag's effects.